Excel has a command that we can use to generate all of these different, not all of them, but most of the information that we use in regression analysis. Okay, but only problem is this will give you the output as numbers and not as formulas, which means if the underlying data changes, then the output that we get will no longer be valid. So you have to run the regression again. Whereas if you set up as formulas like what we have here, if the underlying data changes, all the formulas will be automatically updated. Okay, so you have to remember that caveat. So how do you do that? So go to data and data analysis. If you don't see data analysis here, so that means you have to go and switch it on. So file, options, okay, you have add-ins here. Okay, now Excel add-ins, click go, and make sure that analysis toolpack is checked. Okay, if this is checked, then you will see data analysis there. So click data analysis. Okay, so here there are a bunch of data analysis options available for us. Select regression. Okay, then you see this screen. So there are several things that you can choose from. So first is Y range, and Excel allows you to include a label. Okay, if you check this, then you can start with a label, in which case Excel will strip the first cell as and keep it as label and use the rest of them as the data. But if you do this and forget to check that, then it will give you an error. On the other hand, if you do this and check, you will not get an error, but 6 will be used as a label, and the data will start from 8 through 9.5. So you have to be very careful. So I'm going to start from here. Okay, that's our Y. This is the X, and I'm going to check that. Now, if you want confidence intervals other than 95%, you can check that here. But otherwise, you'll get 95% confidence interval for the coefficients. Now, you can set the output range to a new workbook or new worksheet ply, or in the same worksheet, okay, at a specified starting point. So I'm going to start from here. Okay. Now click OK. Now you can check some of these boxes to generate additional output results for the regression analysis, but we won't get into these. So we'll stop with that. So click OK. So now we have the output. So let's format the output a little bit. So this is observations is sample size n. So I won't change the decimal places here. So let's align this like that. So okay, 2 decimal places, and let's do significance of f as a percentage. Okay, of course that's going to be exactly same as what we got there, and let's increase. So coefficients here. Okay, so that's our intercept. This is the slope, and the standard error corresponding with the slope. Okay, intercept is usually not interpreted. You know, sometimes you may not have an interpretation at all. So we only deal with the slopes. And t-stat is the t-statistic for the coefficients. Okay, and here is the p-value again. If you have only one x variable, then the p-value both for the f-test and the individual test will be the same. If you have multiple x's, then you will have one significance of f for the overall significance, and then individual p-values for individual x's. And these are confidence intervals for the coefficient. So this is the coefficient 1.25. this is the confidence interval for that B sub 1 or beta sub 1. Okay. And if you indicated a different confidence level, instead of 95% you wanted 99%, then you will find 99% here. If you did not make a choice, then just 95% gets repeated. Okay. Then at the top you have some summary statistics. So this is our R squared coefficient of determination. The multiple R is just a square root of that. So if you take a square root of that, you would get that. Now adjusted R squared is something that you can do in multiple regression. It has more relevance. So we'll talk about adjusted R square when we look at multiple regression. Standard error is the estimate of the common variance. Remember, one of the assumptions that we made is all of those normal distributions have the same variance, and you take the standard deviation of that variance. So this is the estimate of that standard deviation, and that is always equal to square root of MSE. MSE is the estimate for variance, and that is the standard deviation is of that. So if you take a square root of that, and you'll get that. Okay, that and that are related. Okay, so that's it. So that's our regression analysis output.